Welcome to another ReInBlock screencast. In this screencast, we're going to take another dive into Liquity, and this time we're going to check out their deployment of the graph. And in this screencast, what we'll focus on is how to spin up the local development environment that Liquity have provided in their open source repository. So if you are not sure about what Liquity is, you can check their website here. And I've also made a few previous screencasts, which I'll link to in the description below. Now, Liquity uses a service called The Graph, which is an API that basically indexes all the data from various blockchain deployments, various smart contracts deployed on the blockchain, and presents them in a nice, easy-to-use GraphQL endpoint. And I can dive more deeply into this and how this works in another screencast, but for now, this is the service that Liquity have used. We can check their subgraph here by going to this page, and you can see that the Liquity subgraph is available here, and there's a playground where we can run queries like this one to get the data such as this from the graph. So the graph is basically an indexer of data from the blockchain, and it uses the events and mapping the events to various tables and logic in a Postgres database that's deployed in the graph. Now, I'm going to be using this repo here from Liquity. This is under the Liquity project, and the repo is called dev. And this is essentially the Liquity monorepo, which contains all of their contracts, SDKs, as well as the subgraph. So over in my console, I've already cloned the Liquity monorepo, and I'm ready to begin the process of running the subgraph locally, just for development purposes. So the way to do this is you first of all want to run yarn to install all the dependencies. Okay, looks like that has been completed. And one other thing to notice is in the output that after installing the dependencies, it also runs a number of different commands to prepare the environment for us. So it runs this prepare star, which basically runs various things like generate types here, and does an API extractor for the documentation, and a lot of other things as well. Now, once that is done, we're able to spin up the graph locally, right? So what we can do is we can check out the package within the monorepo. So I'm going to clear this out. And if you look inside the folder packages and then subgraph, you can see that there is the sort of package underneath the monorepo that is specifically for this subgraph project that we want to try out. And so you notice there's a README file. So I've already opened this in a code editor. So let's flip over to the code editor and take a look at that. So as you can see, the README file basically gives you step-by-step instructions on how to set this up in your local development environment. The way that we can do this is we need to start what they call a Liquity dev chain. And what this is basically a Docker container that Liquity basically download through Docker Hub, and then they spin up a locally running open Ethereum blockchain, which they then deploy their contracts to. So this is what start dev chain does. And we can head over to our console and start yarn dev chain like so, yarn dev chain, and this will start up the chain for us and deploy the contracts. Now you might get this error here. The error will happen at this point, and you'll get this error that sort of says cannot connect to network dev. Now this is because it relies on and requires Docker, and you'll see that in the prerequisites of the repo. So what you need to do is install Docker and start Docker as well, start the Docker service, which I'll do now. Okay, now that Docker has started, I can maybe keep this over here so you can see. I'll just make this a bit smaller. And then we can clear that out and we can run this again. And what you should see is that it will spin up the Open Ethereum container here, and it will deploy the contracts to that container. As you can see here, it's deployed the contracts. These are the addresses. of the contracts deployed. So I'll just expand this out again. And that's complete. So let's head back over to the README and check what the next step is. Now the next step is where it says somewhere else, clone the graph node. Now the graph node is basically it's the GraphQL node. We can take a look at that in here in the browser real quick. So it's from Graph Protocol. And it's basically a graph node service that indexes the data from the blockchain. So essentially what this is this is the open source node software that runs as part of the graph, right? And so we're going to clone this and spin it up locally. So we'll head back over to our terminal here, and I'm just going to collapse this window and show you here in this window that I've already cloned this repository from GitHub. So what I'm going to do in order to run this, I need to cd first into Docker, and then I need to run docker-compose up. And I'm going to leave off the -d because I want to see the logs output directly in the console. So once you see this, the node is running, and you can see that there are actually 3 services that are spun up in this Docker Compose service. So you got Postgres, which is the standard relational database that we all know and love. We've also got an IPFS node that's running. This is used by the graph for storing some metadata. And then we've got the graph node itself, which is spun up and running, and it's connecting to Postgres and IPFS. Moreover, it's also connected to our running blockchain that we started earlier. But now what we got to do is tell the graph node about our subgraph and deploy our subgraph to that node. And that's the next step. So if I head back over to the README, we can see how to do that. So by the way, we're on step number 6 now because we've already started the graph node, and I started it without the -d, so I'm getting the logs already in the console. So step 6 says, back in the Liquity repo, we need to deploy the subgraph to the graph node. And so it says, change directory into packages subgraph, and then run yarn prepare node, yarn create local, and yarn deploy local. So let's do that now. So we'll head back over here, I'll collapse that out there, and then I'll go into this window, which is actually the monorepo. And I'm already in the subgraph package folder, so I can start to run those commands. So yarn create local. And as we can see that executed successfully, and you can see over here in the graph that it actually created that subgraph name, which is called Liquity/Liquity. The next command to run is yarn prepare local. And let's just expand the screen here and just run through very quickly what this does. So it's basically prepared a manifest file for the subgraph using the network dev. Now behind the scenes, what this does is it creates a subgraph YAML, which is the manifest file used for subgraph. And it creates this dynamically using the deployed contracts that we made earlier. And it picks that up from the contract config file that was produced when we deployed the contracts. And then using that, it's able to fill in the missing gaps, such as the address and the block number for the deployment and various other bits of data that come from that deployment manifest. So now we've got that created. The last step is to run yarn deploy local. And now we've got that set up. The last step is to run yarn deploy local, like so. And there we go. And as you can see, what's happened is the deployment has completed on this side, on the left side here where I ran the script. And on the right side, we can see that the graph node that we have running in Docker has picked up that deployment, and it's started to index the blockchain for events. So the final step is to spin up the actual dApp and try this out, because what's going to happen is when we spin up the dApp and we create vaults and we add LUSD to the stability pool, or we stake LQTY tokens, any time we interact with the protocol, it's going to emit an event on chain, in this case on the chain that's running locally in our Docker service. And since we've got a graph running locally as well, and it's listening for events on chain, the graph will then index those events and expose them as part of the GraphQL endpoint. So flipping back to the README again, we can see how we can start the Liquity front end by running this command here in the root of the Liquity repo. So let's copy and paste that and put that into our terminal here. And I'll just expand that out. And it looks like the dApp has built. So we can go over to the dApp, which is in the browser here. And this is the familiar Liquity example dApp, where we can just manipulate and play with the protocol as we wish on our local environment. So we start off with actually having no troves created. So let's go ahead and create a couple of troves. Remember that in this environment, when you refresh, it will create a new dynamic wallet, which appears here other than the top right. So if I refresh, you can see the address there changes. And that's why when that happens, I can create a new vault like this. Now, if we go to risky vaults, you can see the 3 vaults that I've just created, each one with its own address. And for this vault I just created, I'll add the LUSD to the stability pool by clicking on deposit, click max, and then click confirm. So just as a reminder, another thing that you'll notice with this environment is that I'm not using MetaMask. The transactions are confirmed right away without having to worry about MetaMask at all. Now, the final thing that we want to test here is the graph. We want to query the graph to see, did those events get fired properly and did they get indexed by the graph that we have running locally on our computer? So let's head back over to the README, and the way that we can open the graph node is here. We just copy and paste this URL, come back to the browser here, paste that in, and now we've got our GraphQL user interface that we can use for querying the graph. Now, if we expand the Explorer over here and I click on troves, like so, and then I click on first, and I'll just leave it at 10 like that. And what I want to see is the collateral and the debt and the ID. And we'll leave it at that and click the run button or the play button. And as you can see, it brings us back the results of the 3 troves that I created earlier. So that means that the graph is indexing the data. As I interact with the dApp, the graph is picking up the data immediately. And let's just test that. Let's refresh and create another trove. So I'll just go in here and I create one for, let's say, $45 ETH and click confirm. So now I've got this trove created, and if I head back over here and click play again, we've now got the 45 ETH trove here, 45 collateral. So that seems to be working. So the great thing about this is now we have a fully localized running version of Liquity with all the contracts deployed to a local blockchain running in Docker, and we also have the subgraph running in Docker. And the dApp is also running on our local environment in this demo mode, which makes it easy and suitable for testing. So I hope you enjoyed this screencast. I hope you found it useful, and you can dig in and start playing with the subgraph using Liquity. And I'll see you in the next screencast.